So, today we're going to talk about something that sounds like it's straight out of a movie, the mission to literally merge our minds with artificial intelligence. And here's the thing, this isn't science fiction anymore. It's happening right now, and it's unfolding along two radically different paths that could, well, redefine what it even means to be human. Let's explore them.
Elon Musk really captured the whole idea with this quote. It's not about just using AI like another app on your phone. Nope, the vision here is a true partnership, a symbiosis between how we think and how machines think. It's a massive, breathtakingly bold idea. But, saying you want symbiosis immediately brings up a huge question.
Right, how would that actually work? How do you connect a wet, biological brain to a cold, digital computer? Well, the answer to that question is sending innovators down two totally distinct roads. One is all about upgrading our biological hardware with surgery. The other, it's about externalizing the very software of our thought.
Okay, let's start with the first path, the hardware approach. This is the one that gets all the headlines, for sure. We're talking about the world of direct, physical brain-computer interfaces, and the company leading the charge here is, of course, Elon Musk's Neuralink.
The basic idea behind Neuralink sounds deceptively simple. If you want to connect a brain to a computer, you've got to physically wire them together. This means surgically implanting a tiny device that can read and translate the electrical signals that your neurons are firing off every single millisecond.
Okay, so how on earth does this even work? This is where it gets wild. First, you've got these probes. They're thousands of flexible threads, each one thinner than a single human hair. They get implanted right into the brain to listen in on what your neurons are doing. Second, a human surgeon can't do this. No way. You need a custom robot. It's been described as being like a sewing machine that operates with insane microscopic precision. And finally, a small device processes all that brain data and beams it wirelessly to a computer. It is just an absolutely incredible fusion of neuroscience and robotics.
And you have to understand, this is all moving at lightning speed. Just look at this timeline. In 2019, they were doing demos with animals. Fast forward to May 2023, and boom, FDA approval for human trials. Then, in January 2024, the very first human patient, a quadriplegic man named Nolan Arbaugh, gets the implant. And by the end of that same year, their project to restore vision, called Blindsight, gets fast-tracked by the FDA. The pace is just relentless.
But what if you didn't need surgery? What if you didn't need to put anything in your brain at all? Well, that brings us to path number 2, which is a completely different way of thinking about this. This is the software path. Instead of jacking into our neurons, it aims to connect to our logic. So this second path starts by trying to solve what's called the dual black box problem. Sounds complicated, but it's not. On one side, you have the human expert's mind. Their gut feelings, their intuition, it's super powerful, but they often can't explain exactly how they do what they do. That's one black box. On the other side, you have the AI's mind. It can make incredible decisions, but its inner workings are often just as mysterious and unexplainable. That's the second black box. The whole goal here is to build a bridge between the two.
So, the big idea here is a total shift in perspective. It's not about using AI as just a powerful tool. It's about creating a true thinking partner. And you do that by building a system that can actually understand, pull out, and even replicate the core logic that a human expert uses to make decisions.
And this is a brilliant way to see how it works. A software framework, this one is called RAMTN, basically mimics critical thinking. It has this 3-part loop. The AI constructor builds an idea. Let's say, we should invest in tech startups. Then, the AI critic immediately jumps in and challenges it. Hold on, why? That's super risky. What about market crashes? Then, the human expert, the observer, steps in to guide the whole process. They might say, good point, let's refine that, focus only on tech startups that already have proven revenue. And the loop just keeps going, forcing the AI and the human to debate and refine until a really solid, clear strategy comes out of it.
And what you get in the end are these incredible plug-and-play cognitive frameworks. I mean, just imagine this. You could take the diagnostic logic of a top cancer specialist and turn it into a software tool for any doctor in any small-town clinic. Or you could scale the teaching methods of a world-class educator for thousands of classrooms. You're not just getting an answer from an AI, you're getting an expert's entire way of thinking. This table really nails the difference from what most of us are used to. With prompt engineering, it's all on us, right? We have to adapt and learn the magic words to get the AI to give us what we want. But with this meta-interaction, it's a two-way street. The human and the AI actually adapt to each other. It's a real dialogue, a real collaboration, and the goal is a much deeper shared understanding. So there you have it, two incredible paths forward, the hardware implants and the software blueprint. Both of them offer a truly world-changing promise, but they also come with some really significant risks and force us to ask some profound questions about where we're headed.
I mean, the potential upside here is just staggering. On the one hand, a brain implant could literally cure things like paralysis and blindness, giving people back functions they've lost. On the other hand, the cognitive blueprint could lead to cognitive equity, where the genius of the world's top experts isn't locked away anymore. It can be scaled for everyone, for the public good. And look, this isn't some abstract future possibility. This is a quote from Noland Arbaugh, the very first Neuralink patient. For him, being able to control a computer with his mind after being paralyzed, well, he said it gave him his life back. That's a powerful reminder of the real human stakes here.
But with that great promise comes great peril. Of course. For the implant, you've got serious surgical risks, and we just don't know the long-term health effects. There have also been major controversies over animal testing. And the ethical nightmares? Hacking, privacy, misuse of your literal thoughts. It's huge. For the software path, the dangers are a little more subtle. What if we create a world of cognitive conformity where everyone starts thinking the same way? Or what if we just end up amplifying the hidden biases of the experts whose logic we're copying?
And let's be super clear, this isn't some far-off future we're talking about. Reports suggest that by late 2025, around a dozen people had already received Neuralink implants. The trials are happening now. They are growing. And all these tough ethical questions are moving from theory into stark reality.
So, here we are, standing at a crossroads, looking at two fundamentally different ideas for how we're going to merge our minds with machines. One is a physical fusion, the other is more like a meeting of minds.
This comparison just lays it all out so clearly. You've got the hardware path, which is invasive and aims for direct brain control by connecting to our neurons. Then you've got the software path, which is non-invasive and is all about creating a cognitive partnership by sharing our logic. It's a fundamental choice. Do we become one with the machine, or do we learn to think alongside it? As that line between our minds and our machines gets blurrier and blurrier, both of these paths are racing forward. The real question isn't just about which one will get there first. It's about what kind of future we're building as we go. Which of these paths is going to define the next chapter of human evolution?